Hi there, welcome to Physics, Chapter 1, Physical Quantities and Measurements, Lesson 3, Prefixes. Now, prefixes is a simple concept to understand, but it is not so simple to actually use them. Alright, now prefixes are basically symbols, used to represent a very large or small value. Alright, now there are 7 prefixes that you will need to remember for ordinary level physics, and these range from giga all the way to nano. Now, these prefixes has a symbol, right? And the symbol for giga, for example, is a capital G. For mega is capital M. Whether they are capital or small letter, it matters a lot. So take note that for all these 7 prefixes, their symbols are correctly written with either the capital or the small letter. Now, I would like to highlight the 6th prefix in the table. That is the micro. The micro has this particular symbol, and this symbol is representing micro. Okay, so do take note of this. Now, what do the prefixes mean? Well, for example, let's go to the top. Giga with the symbol capital G basically represent many multiples of 10. For this particular case, they are 9 multiples of 10. So basically, we rewrite this. If you count the number of zeros here, there are 9 zeros, or we can actually rewrite this in terms of power. So it's actually known as a 10 to the power of 9. 9 here refers to the 9 zeros that appears after the digit 1. So that's a giga. It's a very, very huge number. Now, next in the list that you need to remember is a mega, capital M. Mega itself is used to represent 1 million, 1 million, and we can express that again in the 10 to the power of something, and there is shown to be 10 to the power of 6 because there are 6 zeros after the 1. The third one in the list is the kilo. Kilo has a symbol small k, and the kilo represents 1,000, multiples of 1,000, or 3 multiples of 10. So this is written as 10 to the power of 3. Now, we move on to prefixes that is used, prefixes which are used to represent small numbers, in particular fractions. Centi, the symbol small c, is used to represent a fraction of 1 out of 100th. In other words, we can rewrite this in the 10 to the power of negative 2. The negative 2 here is used to mean that to denote that it's actually a fraction, and there are 2 numbers, 2 zeros here, therefore it becomes 2. Milli, small m, is used to represent a fraction of 1 over 1,000, and is written as 10 to the power of negative. Again, let me repeat, the negative refers to the fraction, and the 3 here refers to the 3 zeros that comes after the 1. Micro is again representing a very small number, and it is used to represent 1 over a million. So we write it down as 10 to the power of minus 6. Nano, the last on the table, is used to represent 1 over 1,000 million. In other words, it's written down as 10 to the power of minus 9. So the last 3 here in particular are prefixes which are used for very, very small values. Now, how do we use the prefixes? Let's look at the first example. A USB drive has a storage space of 5 capital GB. We call this 5 GB. We read this out as gigabytes. Now, if you recall, giga represents a very large number. So on the next line, we can rewrite this down as 5 gigabyte. And 5 gigabyte is simply 5 times 10 to the power of 9 bytes, because giga represents 10 to the power of 9, or 1 followed by 9 zeros. Since it saves us time, instead of writing so many zeros, we can simply write it down in this 10 to the power of 9. Now, if you want to break it out, and expand it, this is what we can write down. Since it's 5 times 10 to the power of 9, we can write it down in its long string as 5 followed by 9 zeros at the back. Now let's look at the next example. Diameter of a lead atom is about 0.15 nanometer. Nanometer. So 0.15 nanometer Recall again, nano represents a very small value. So we rewrite the actual value of the lead atom, 0.15, multiplied by 10 to the power of minus 9. So this shows that the diameter of a lead atom is actually very, very, very small. Example number 3. A plant cell has a length of about 7.5 micrometers. This symbol is the micro, representing micro. So 7.5 micrometers can also be written down in terms of the 10 to the power. So this is 7.5 times 10 to the power, if you remember, micro represents 10 to the power of minus 6 meters. Alright, now at this point we have been talking about 10 to the power and 10 to the power. Now it is a good time now to introduce the actual term for this. This times 10 to the power of something is known as the standard form in math. Alright, so when I use the term standard form, I'm actually referring to a 10 to the power of something. Okay, from this point onwards. Now let's have a look at the second example here. For example, Mount Everest is known to be 8,848 meters tall. So in terms of meters, it's written down in this way. And if you want to express this in prefixes, how do we do that? Well, remember that the kilo prefix, small k, is used to represent 1,000 or 10 to the power of 3. So if that's the case, by looking at this 8,848, we can actually break it down into 8.848 multiply 1,000 meters. This will give us the same value here. And since 1,000 is represented by the symbol kilo, by kilo prefix, and we can replace that with a simple symbol k. Okay. Next example, an animal cell is about 3.5 times 10 to the power minus 6 meters long. So if you recall, 10 to the power of minus 6, this standard form, is a very small value, and this can be represented by the prefix micro. So instead of writing the standard form, we can rewrite it simply as 3.5 micrometer. Now, it's your turn. Why don't you try this? 20 megameters. This simply can be written down as 20 in terms of standard form, 20 multiplied 10 to the power of 6. If we expand it, this is how it should look like. How about 1502 centimeters? How can we write that down in terms of meters? Well, if you recall, centimeter is a prefix that is used to represent 1 over 100 or 10 to the power of minus 2. If that's the case, we can rewrite it down as simply 15.02 meters. Okay, how do you get this? We simply multiply this 1502 by 1 over 100. 1 over 100 is used to substitute the centi prefix. 1, 2, 3, 4, 5, 6 micrometer. How do you write that down in meters? Well, remember the micro itself represents 1 over a million. So we replace this by 1 over a million and we multiply that by 1, 2, 3, 4, 5, 6, and that should give us 0.123456 of a meter. Now the last question is 150 milligram. How do we convert that to kilogram? This is a little bit more challenging. Now a milli itself, if you recall, represents 1 over 1,000, okay, or 10 to the power minus 3. Whereas a kilo is representing 10 to the power of 3 instead. So how do we convert this? If you work it out in the paper, you should find that it is equals to 0.00015 kilogram. Well, that is the end of this lesson. So a quick summary for this lesson number 3, we have talked about prefixes, and it's important to remember the table of all the prefixes starting from giga all the way to nano. Take note as well, the symbols matters, the size of symbols, the capital or the small letters matters a lot. Okay, right, that brings us to the end of the video. Thank you for listening.